Now in this lecture we will find the radius of the circle. In the drawing we have a circle, and inside the circle we have quadrilateral ABCD. So quadrilateral ABCD is inscribed by this circle, and we also know that the side AB of this quadrilateral equals to 3 units. So we define AB as A, so A will be equal to 3 units. And we also know that side BC of quadrilateral ABCD equals to 4 units. Therefore, we define side BC as B, that is to say BC equals to B, and B equals to 4 units. And we also know that side CD of quadrilateral ABCD equals to 5 units. Therefore, we will define side CD of quadrilateral ABCD as C, that is to say CD equals to C, and therefore C will be equal to 5 units. And we also know that side AD of quadrilateral ABCD equals to 6 units. AD equals to 6 units, therefore we will define side AD as D, that is to say AD equals to D, therefore D will be equal to 6 units. Okay, and we want to find out the radius of this circle that blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle, and we want to find out the radius of this circle. So first of all, I will present to you 3 new rules, and we will implement the 3 new rules in our drawing. So rule number 1 will be rule number 1 states that the area of a quadrilateral inscribed by a circle equals to suppose the quadrilateral is ABCD, then the area of quadrilateral ABCD that is inscribed by a circle. This is the sign of area of a quadrilateral. So the area of a quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the quadrilateral sides, and S equals to A plus B plus C plus D over 2. So actually, if we have this circle and this circle blocks quadrilateral ABCD, so actually this is quadrilateral ABCD, and we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD of quadrilateral ABC equals to C units in its size, and side AD of quadrilateral ABC D equals to D units in its size. So according to rule number 1, the area of this quadrilateral ABCD equals to area of quadrilateral ABCD again. This is the sign of area of a quadrilateral. The area of quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D, where A, B, C, and D are the lengths of quadrilateral ABCD sides. So I already said side AB equals to A units in its size, side BC equals to B units in its size, side CD of quadrilateral ABC equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size, and S equals to the sum of quadrilateral ABCD sides. This is to say is equals to A plus B plus C plus D over 2. Okay, so whenever you have a quadrilateral that is inscribed by a circle like in this drawing, then the area of this quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D. Again, A, B, C, and D are the lengths of quadrilateral ABCD sides, and S equals to A plus B plus C plus D over 2. Okay, so that is all number 1, and we also have all number 2. According to all number 2, if a quadrilateral is inscribed by a circle, if a quadrilateral is inscribed by a circle, like in this original drawing, quadrilateral ABCD is inscribed by this circle, then the products of its diagonals equals to the sum of the products of its opposite sides. I will repeat on rule number 2 again. Rule number 2 states that if a quadrilateral is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So, what is the meaning of rule number 2? Actually, the meaning of rule number 2 is that if we have this circle and we have a quadrilateral ABCD that is blocked by this circle, like in this drawing. So we have quadrilateral ABCD this quadrilateral ABCD quadrilateral ABCD is blocked or is inscribed in this blue circle, and we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, that is to say BC equals to B, side CD of quadrilateral ABCD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. And we also know that diagonal BD this diagonal BD of quadrilateral ABCD equals to X units in its size, that is to say BD equals to X. And we also know that diagonal AC, this diagonal AC of quadrilateral ABCD equals to Y units in its size, that is to say AC equals to Y. Then according to rule number 2, the product of its diagonals, I'll repeat again, diagonal ABCD as quadrilateral ABCD has two diagonals, diagonal BD and diagonal AC, and we know that the size of diagonal BD equals to X units and the size of diagonal AC equals to Y units. Then the product of its diagonals, that is to say X times Y, equals to, according to rule number 2, to the sum of the products of its opposite sides. Diagonal quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is side AD is opposite to side BC, and AD equals to D units in its size, and BC equals to B units in its size. Therefore, the product of its first opposite sides is B times D, and the product of its second opposite sides, actually the second opposite sides is side AB is opposite to side CD, and we know that side AB equals to A units in its size and side CD equals to C units in its size. So the product of its second opposite sides, it is actually A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD, and the second product of its opposite sides is AC, and the sum of the products of its opposite sides is BD plus AC, and according to rule number 2, BD plus AC, that is actually the sum of its opposite, that is the product, that is the sum of the products of its opposite sides. Again, BD plus AC is the sum of the products of its opposite sides, because of the fact that BD is the first product of its opposite sides, and AC is the second product of its opposite sides, and BD plus AC is the sum of the products of its opposite sides, and that sum of the product of its opposite sides, that is BD plus AC, equals to the products of its diagonals, that is to say it equals to x times y. I'll repeat again, the product of its diagonals is x times y, and that product x times y, the product of its diagonals, that is x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. Okay, so whenever you have a quadrilateral that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, that is to say equals to BD plus AC. Again, x times y, that is the sum, that is the product of its diagonals, equals to the sum of the products of its opposite sides, that is actually BD plus AC, or xy equals to BD plus AC. The sum, the product of its diagonals, that is x times y, equals to the sum of the products of its opposite sides, that is actually BD plus AC. Okay? I repeat again, if a quadrilateral is inscribed by a circle, like in this drawing we have quadrilateral ABCD that is inscribed by this blue circle, then the product of its diagonals, the product of the diagonals of quadrilateral ABCD is actually x times y, and this product x times y equals to the sum of the products of its opposite sides, equals to the sum of the products of its opposite sides, that is to say it equals to BD. BD is the first product of its opposite sides, and AC is the second product is the second product of its opposite sides, and the sum of the products of its opposite sides, it is actually BD plus AC, and that sum of the products of its opposite sides, that's actually BD plus AC, equals to the product of its diagonals, that is to say it equals to x times y. Okay? So actually that is rule number 2, and we also have rule number 3. According to rule number 3, rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle, that blocks the triangle, I repeat again, the radius of that circle, which circle? The radius of that circle that blocks that triangle equals to the product of the triangle's sides over 4 times the area of that triangle. Again, I repeat, which triangle? Over 4 times the area of that triangle. The triangle that is inscribed by that circle. So I'll repeat on rule number 3 again. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle that blocks the triangle equals to the product of the triangle's sides over 4 times the area of that triangle that is inscribed by the circle. I will explain what is the meaning of rule number 3. The meaning of rule number 3 is that if you have this circle and this circle blocks a triangle, or a triangle ABC, this triangle ABC is inscribed by this blue circle. As you can see from the drawing, this triangle ABC is inscribed by this blue circle, and we also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. And according to rule number 3, if a triangle is inscribed by a circle, as you can see in this drawing, the red triangle ABC is inscribed by the red circle, then the radius of that circle, the radius of this circle that blocks triangle ABC, the radius of this is, that is to say capital R, the radius of this circle that blocks the red triangle ABC will be equal to the product of the triangle sides. The product of the triangle sides is actually A times B times C over 4 times the area of that triangle, over 4 times the area of this red triangle, the area of the red triangle, triangle ABC. I will repeat on rule number 3 again. If we have a triangle that is inscribed by a circle, like in this drawing, we have the red triangle ABC is inscribed by the blue circle, then the radius of that blue circle that blocks the red triangle ABC will be equal to the product of the triangle sides. The product of triangle ABC sides is A times B times C over 4 times the area of that triangle, over 4 times the area of the triangle ABC. So if you have a triangle that is inscribed by a circle, like in this drawing, then the radius of the circle that blocks that triangle will be equal to the product of the triangle sides, that is to say will be equal to A times B times C over 4 times the area of that triangle that is blocked by that circle, over 4 times the area of triangle ABC that is inscribed by this blue circle. Again, R, the radius of a circle that blocks a triangle, equals to the product of the triangle sides, that is to say equals to A times B times C over 4 times the area of this triangle that is inscribed by the blue circle over 4 times the area of triangle ABC, or capital R equals to A times B times C over 4 times the area of this triangle ABC that is inscribed by this circle. Okay, so that is rule number 3, and we'll actually implement all 3 rules in our drawing. This is our original drawing. We have quadrilateral ABCD that is inscribed by this circle. So according to rule number 1, the area of this quadrilateral that is inscribed by that circle, that is to say the area of quadrilateral ABCD, according to rule number 1. I will repeat again. This is the sign of the area of quadrilateral ABCD, will be equal, according to rule number 1, to the root of S minus A times S minus B times S minus C times S minus D. So here A, B, C and D are the lengths of this quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. That is to say, it equals to the sum of the quadrilateral sides over 2. That is actually rule number 1, or actually the implementation of rule number 1 in our drawing. That is rule number 1, and we will implement rule number 2 in our specific drawing. The implementation of rule number 2 in our drawing, first of all, we will draw the two diagonals of this quadrilateral ABCD. The first diagonal of quadrilateral ABCD will be equal to DB, and the size of diagonal DB is x units according to our definition. That is to say, DB equals to x. And the second diagonal of quadrilateral ABCD will be AC, and the size of diagonal AC, the size of this diagonal AC equals to y units in its size. That is to say, AC equals to y. So according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides, side BC, is opposite to side AD in quadrilateral ABCD, and the product of those two opposite sides is B times D. And the second product of its opposite sides, or the second opposite sides in quadrilateral ABCD, is side AB is opposite to side CD, and the product of those two opposite sides is actually A times C. And according to rule number 2, the sum of the products of the two opposite sides is BD plus AC, and this sum of products of its opposite sides equals to the product of its diagonals. That is to say, it equals to x times y. So the implementation of rule number 2 in our drawing is x times y, the product of its diagonals, equals to the sum of the products of its opposite sides, equals to BD plus AC. I will repeat again. According to rule number 2, xy equals to BD plus AC. That is actually the implementation of rule number 2 in our drawing. And we will implement rule number 3 also in our drawing. If we relate to this triangle ABC, so in relation to triangle ABC, as you can see from the drawing, this triangle ABC, is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the sum, the product of the triangle's sides, the product of triangle ABC sides, that is to say, it will be equal to A times B times Y over 4 times the area of this triangle over 4 times the area of triangle ABC. I repeat again, we have here triangle ABC. Triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides. That is to say, it will be equal to A times B times Y over 4 times the area of the triangle, over 4 times the area of the triangle ABC that is blocked by this circle, or over 4 times the area of triangle ABC that is inscribed by this circle. That is the implementation of rule number 3 in our drawing. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that R, the radius of the circle, times the area of triangle ABC equals to ABY over 4. So here we will divide equation number 3 by R, and we will get that the area of triangle ABC, according to equation number 3, equals to ABY over 4R. Okay? Again, we divided this equation number 3 by R, and we got that the area of triangle ABC equals to ABY over 4R. Okay, so we found the area of triangle ABC. In the next step, we will focus on triangle ADC. This triangle ADC. As you can see from the drawing, this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangles ADC sides, that is to say, it will be equal to C times D times Y over 4 times the area of this triangle ADC. Okay, So I repeat again, this triangle ADC is blocked by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times Y over 4 times the area of this triangle ADC over 4 times the area of triangle ADC. This is actually according to rule number 3. Okay? So here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to C dy over 4. Here we will divide equation number 4 by R, and we will get that the area of triangle ADC according to equation number 4 equals to C dy over 4R. We found out that the area of triangle ADC equals to C dy over 4R. Okay? But as you can see from the drawing, quadrilateral ADC, this quadrilateral ABCD, consists of those two triangles, triangle ABC and triangle ADC. It consists exactly those two triangles, triangle ABC and triangle ADC. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC, because quadrilateral ABCD consists exactly those two triangles. Therefore, the area of those the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. So I will write it down that the area of quadrilateral ABCD, this will be equation number 1. According to the drawing, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Very simple. You can see it from the drawing that the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Okay? I will repeat again. The area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. Okay? So the area of quadrilateral ABCD equals to the area of triangle ABC, but we have already found out that the area of triangle ABC equals to ABY over 4R plus the area of triangle ADC. But we have already found out that the area of triangle ADC equals to C dy over 4R. So here we will take a common factor a common factor y over 4R out of these expressions, and we will get that the area of quadrilateral ABCD according to equation number 1 equals to, we take y over 4r is a common factor, and what's left after we took y over 4r as a common factor of these two expressions. In the brackets we will have here only AB left, so we took y over 4r as a common factor, and here what is left after we took y over 4r as a common factor, what is left is actually CD. So we actually found out that the area of quadrilateral ABCD equals to y over 4r times AB plus CD. Okay, so this will be our first equation for the area of quadrilateral ABCD. Then we will focus on triangle BDC. Okay, on triangle BDC, actually, as you can see from the drawing, this triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of this triangle over 4 times the area of triangle BDC. This is according to rule number 3. I repeat again. This triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of this triangle, over 4 times the area of triangle BDC. So this will be equation number 5. We will multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCX over 4. Here we will multiply equation number 5. We divide equation number 5 by the radius of the circle that blocks triangle BDC, and we will get that the area of triangle BDC that is blocked by the circle will be equal to BCX over 4R. Okay? In the next step, we will focus on triangle ABD. Okay, triangle ABD. This triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say, it will be equal to A times T times X over 4 times the area of triangle ABD. That is according to rule number 3. I will repeat again. Triangle ABD, this triangle is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to product of triangle ABD sides, that is to say, it will be equal to A times D times X over 4 times the area of triangle ABD. Okay, here we will multiply equation number 6 by the area of triangle ABD, and we will get that R times over the area of triangle ABD equals to A bx over 4. So we multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle BDC equals to BC equals to we multiplied equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADX over 4. ADX over 4. Here we will divide equation number 6 by the radius, by R, and we will get that the area of triangle ABD, according to equation number 6, equals to ADX over 4R. Okay? And we have already found out that the area of triangle BDC, according to equation number 5, equals to BCX over 4R. So, as you can see from the drawing, the area of triangle BDC plus the area of triangle ABD, the sum of the areas of those two triangles, equals exactly to the area of triangle AB, equals exactly to the area of quadrilateral ABCD. I will repeat again. The area of triangle BDC plus the area of triangle ABD equals exactly to the area of quadrilateral ABCD. I will write down. that the area of quadrilateral ABCD, according to equation number 2, equals to the area of triangle BDC plus the area of triangle ABD. As you can see from the drawing, quadrilateral ABCD consists exactly those two triangles, triangle BDC plus and triangle ABD. Therefore, the sum of the areas of those two triangles equals to the area of quadrilateral ABCD. Okay, so the area of quadrilateral ABCD according to equation number 2 equals to the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCX over 4R. That's the area of triangle ABD. We have already found out that the area of triangle ABD equals to ADX over 4R. So here we take out a common factor BCX, we take a common factor x over 4R out of these expressions, and we'll get that the area of quadrilateral ABCD according to equation number 2 equals, we took a common factor x over 4R out of these expressions, x over 4R. So what is left inside the brackets? Inside the brackets, what is left here is BC, and what is left here in this expression after we took x over 4R from this expression, what is left is AD. So we actually found out that the area of quadrilateral ABCD according to equation number 2 equals to x over 4R times BC plus AD. But we have already found out, according to equation number 1, that the area of quadrilateral ABCD equals to y over 4R AB plus CD. So we actually have two different expressions for the area of quadrilateral ABCD. In the next step, we'll multiply equation number 1 by equation number 2, and we will get equation number 3, that is actually the area of quadrilateral ABCD squared. Okay, and it will be equal to x times y. In the denominator, we will have 4R squared, and in the numerator, we will have BC plus AD times AB plus CD. Okay, so here we will take a root out of equation number 3, and we will get that the area of quadrilateral ABCD equals to the root of this expression in the numerator will be inside the root. So it will be equal to xy BC plus AD times AB plus CD. And in the denominator we will have actually the radius, the root of 4r squared equals to 4r. Why? Because the root cancels the square, because those are two opposite operations, and what left is only 4r. So we actually got that the area of quadrilateral ABCD equals to the root of xy, and in the brackets we have BC plus AD times AB plus CD over 4r. Okay, so here we will multiply equation number 3 by r, and we will get that equation, according to equation number 3, r times the area of quadrilateral ABCD will be equal to the root of xy BC plus AD times AB plus CD, all divided by 4. Okay, I will repeat again. We actually multiplied this equation number 3 by r, and we got this expression. So here we will divide equation number 3 by the area of quadrilateral ABCD, and we will get that the radius that we are looking for equals to, according to equation number 3, the radius of the circle that we are looking for equals to the root of xy BC plus AD and AB plus CD, all divided by 4 times the area of quadrilateral ABCD. Okay, so we actually found out the radius that we are looking for, the radius of the circle that blocks quadrilateral ABCD. Okay, the radius of the circle, and we have already found out that according to equation number 2, xy equals to AC plus BD. This is true according to rule number 2. Therefore, we can substitute xy in equation number 3 by AC plus BD that equals to xy. So we'll substitute xy by AC plus BD, because AC plus BD equals to xy, and we will get that the radius of the circle that blocks quadrilateral ABCD equals to xy equals to AC plus BD. So we'll substitute xy by AC plus BD, and we have here BC plus AD, BC plus AD, and we have here AB plus CD. All divided by 4 times the area of quadrilateral ABCD. The only thing that is left to do is to find out the area of quadrilateral ABCD, because we already know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. Therefore, the only thing that is left to do in order to find out the radius of the circle that blocks quadrilateral ABCD is to find out the area of quadrilateral ABCD, and we will find out, actually we have already found out the area of quadrilateral ABC, the area of quadrilateral ABCD, and I will repeat on that again. We actually, according to rule number 1, we have already found out that the area of quadrilateral ABCD, according to rule number 1, equals to the root of S minus A times S minus B times S minus C times S minus D. While when A, B, C, and D are the lengths of quadrilateral ABCD sides, okay, and S equals to A plus B plus C plus D over 2. Okay, I write down the values of A, B, C, D. A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. And so therefore we can easily find out the value of S. S equals to A plus B plus C plus D. It is actually 3 plus 4 plus 5 plus 6 over 2. 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18, 18 over 2 is 9. 18 over 2 is 9, so we actually found out that S equals to 9. So here we will substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD equals to the root of S is 9, so, and A is 3, so it is 9 minus 3, S is 9, and B is 4, so it is 9 minus 4, S is 9, and C is 5, so it is 9 minus 5, and S is 9, and D is 6, so it is actually 9 minus 6. So in total we found out that the area of quadrilateral ABCD, the area of quadrilateral ABCD equals to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So it actually the area of quadrilateral ABCD, according to this equality, equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Okay, so we'll substitute the we'll substitute the area of quadrilateral ABCD that we found out in equation number 3 by the root of 360. Okay, here we substitute this the area of quadrilateral ABCD by root 360 square meters, square units. And we will get that the radius that we are looking for equals to the root of AC plus BD, AC plus BD, BC plus AD, AB plus CD. And the area of quadrilateral ABCD equals to the root of 360 square units. So we got that the radius that we are looking for equals to this expression. Again, we know that A is 3, B is 4, C is 5, and D is 6. Okay, so write it here, and we will put the data inside this equality, and we will find out the area of the circle that blocks quadrilateral ABCD. That will be the answer to the question. Okay, I will write here that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units according to what is given us in the question. And then we find out the radius of the circle that we are looking for will be equal to the root of A is 3, C is 5, 3 times 5 is 15, BD, B is 4, D is 6, 4 times 6 is 24, BC, B is 4, C is 5, 4 times 5 is 20, A is 3, D is 6, 3 times 6 is 18, A is 3, B is 4, 3 times 4 is 12, CD, C equals to 5, D equals to 6, 5 times 6 is 30, all divided by 360, so it is actually the root the radius of the circle equals to 15 plus the root of 15 plus 24 is 39, and 20 plus 18 is 38, and 12 plus 30 is 42, all divided by 360 divided by 4. So the radius of the circle equals to the root of 39 times 38 times 42 over 66 over 36, all divided by 4. Actually, the expression inside the square equals to 172.9 all divided by 4. So the answer to the question is that the radius of the circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle that blocks quadrilateral ABCD equals to 3.287 units. Okay, so I will repeat on the question, on the answer. The radius of this circle that blocks quadrilateral ABCD will be equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this circle, and inside the circle we have quadrilateral ABCD. We know that AB equals to 3 units, BC equals to 4 units, CD equals to 5 units, and AD equals to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. Okay? So first of all, I presented to you 3 rules, and we implemented the 3 rules in our drawing. We have rule number 1. Rule number 1 states that the area of a quadrilateral inscribed by a circle equals to, this is the sign of area of quadrilateral ABCD, it equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABCD sides, the red quadrilateral, and S equals to A plus B plus C plus D. So whenever you have quadrilateral that is inscribed by a circle like in this drawing, then you can find the area of this quadrilateral by using this equation. Okay, that is rule number 1. And we also have rule number 2. According to rule number 2, if a quadrilateral is inscribed by a circle, like in this drawing, you can see that quadrilateral ABCD in the red color is inscribed by the blue circle. So if a quadrilateral is inscribed by a circle, then the products of its diagonals, is actually x times y, because we have diagonal AC equals to y units in its size, and diagonal BD of quadrilateral ABCD equals to x units in its size, and the product of the diagonals, equals to x times y. Okay, the product of its diagonals is x times y, and it equals to the sum of the products of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. Side BC is opposite to side AD. BC equals to B units and AD equals to D units. Therefore, the product of the first opposite sides is actually B times D. And we have also second pair of opposite sides. Side AB is opposite to side CD in quadrilateral ABCD. And the size of side AB is A units and the size of side DC is C units. Therefore, the product of those two opposite sides is A times C. So actually we have two products of the two pairs of opposite sides of quadrilateral ABCD. The first product of the first pair of opposite sides is B times D, and the second product of the second opposite sides is A times C. And according to rule number 2, the sum of the products of the two opposite sides is actually the two pairs of opposite sides. The sum of the product of those two opposite sides is BD plus AC. And that sum equals to the product of its diagonals. And the product of its diagonals is x times y, and that product equals to the sum of the products of its opposite sides. That is to say, it equals to BD and AC. Why? Because the first product of its opposite sides is BD. The second product of its opposite sides is AC. And the sum of the product of its opposite sides, it is actually BD plus AC. And that sum equals to the products of its diagonals, that is actually x times y, or x times y equals to BD plus AC according to rule number 2. Okay? So if a triangle is inscribed by a circle like A, so actually according to rule number 2, if a quadrilateral is inscribed by a circle like this, quadrilateral ABCD is inscribed by this blue circle, then the product of its diagonals, is x times y, and that product equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is actually BD plus AC, and BD plus AC equals to xy. Okay, that is rule number 2, and we also have rule number 3. According to rule number 3, if a triangle is inscribed by a circle, like in this drawing, we have triangle ABC, the red triangle that is inscribed by the blue circle. Then, according to rule number 3, the radius of that circle, equals to the product of the triangle sides over 4 times the area of that triangle. So if a triangle is inscribed by a circle like in this drawing, we have triangle ABC that is inscribed by the blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangles ABC sides. That is to say, it will be equal to A times B times C over 4 times the area of this triangle, over 4 times the area of triangle ABC, or the radius of a circle that blocks triangle ABC will be equal to the product of the triangles ABC that is blocked by the circle. That is to say, it will be equal to A times B times C over 4 times the area of this triangle, over 4 times the area of triangle ABC. So whenever you have a triangle that is inscribed by a circle, then the radius of the circle that blocks the triangle will be equal to the product of the triangle's sides that is blocked by the circle over 4 times the area of the triangle that is blocked by the circle. So R, the radius of the circle that blocks the triangle, will be equal to the product of the triangle sides. That is to say, it will be equal to A times B times C over 4 times the area of the triangle that is blocked by the circle. Or R equals to ABC over 4 times the area of triangle ABC in this case. Okay, this is all number 3. And we actually implemented all 3 rules in our drawing. According to rule number 1, the area of this of our quadrilateral ABCD equals to this expression, to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of the quadrilateral sides, and s equals to a plus b plus c plus d over 2. That is rule number 1. And we also implemented rule number 2 in our drawing. According to rule number 2, if we have a quadrilateral ABCD that is inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to BD plus AC. Okay? According to rule number 2, xy equals to BD plus AC. And we also implemented rule number 3 in our drawing. We focused on triangle ABC. As you can see from the drawing, triangle ABC is blocked by the blue circle, or triangle ABC is inscribed by this circle. Therefore, according to rule number 3, the radius of the circle that blocks triangle ABC will be equal to the product of the triangle's sides that is blocked by this circle. That is to say, it will be equal to A times B times Y. The radius of the circle that blocks triangle ABC will be equal to the product of the triangle's sides, that is A times B times Y, over 4 times the area of triangle ABC that is blocked, that is inscribed by the circle. So R equals to ABY, that is the product of the triangle's sides, over 4 times the area of the triangle that is inscribed in the circle. That is the radius of the circle that blocks triangle ABC, according to rule number 3. So here we multiplied equation number 3 by the area of triangle ABC, and we got R times A, the area of triangle ABC equals to ABY over 4. Here we divided equation number 3 by R, and we got that the radius, that the area of triangle ABC, according to equation number 3, equals to ABY over 4R. Then we focused on this triangle, triangle ADC. As you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of the sides of the triangle that is blocked by the circle. That is to say, it will be equal to C times D times Y over 4 times the area of triangle ADC, over 4 times the area of triangle ADC. That is according to rule number 3. We multiplied equation number 4 by the area of triangle ADC. We got this expression, and then we divided equation number 4 by r, and we got that the area of triangle ADC equals to CDY over 4r. Okay, and what is the area of triangle of quadrilateral ABCD? Quadrilateral ABCD consists of 2 triangles, triangle ABC and triangle ADC, and the area of quadrilateral ABCD will be equal to the area of the 2 triangles that it consists of. The area of triangle ABC plus the area of triangle ADC. So the area of quadrilateral ABC plus the area of triangle ADC equals to the area of quadrilateral ABCD. But we have already found out that the area of triangle ABC equals to ABY over 4R, and the area of quadrilateral ADC equals to CDY over 4R. Here we took out the common factor of y over 4r of these expressions, and we got that the area of quadrilateral ABCD according to equation number 1 equals to y over 4r times AB plus CD. Then we focused on triangle BDC. As you can see from the drawing, this triangle BDC is inscribed by this circle. Therefore, according to rule number 3, the radius of the circle that blocks triangle BDC will be equal to the product of its sides. That is to say, it will be equal to B times C times X. The radius of the circle will be equal to B times X, B times C times X over 4 times the area of triangle BDC. Here we multiplied equation number 5 by the area of triangle BDC, and we got this expression. And then we divided the equation number 5 by r, and we got that the area of triangle BDC equals to BCX over 4r. Then we focused on triangle ABD, on this triangle ABD. As you can see from the drawing, you can see that the triangle ABD is inscribed by this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangles ABD sides. That is to say, it will be equal to 8 times D times X, 8 times D times X over 4 times the area of triangle ABD. Here we multiplied equation number 6 by the area of triangle ABD, and we got this expression. Then we divided equation number 6 by r, and we got the area of triangle ABD equals to ABX over 4r. And we have already found out that the area of triangle BDC equals to BCX over 4r. And we know that the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD, because quadrilateral ABCD consists of those two triangles. It consists exactly of those 2 triangles. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABDC plus the area of triangle ABD. Okay? The area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD. But we have already found out that the area of triangle BDC equals to BCX over 4r, and the area of triangle ABC equals to ADX over 4R. Here we took out the common factor of x over 4R out of these expressions, and we got that the area of quadrilateral ABCD equals to x over 4R times BC plus AD. And we have already found out in equation number 1 that the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Okay, so we have two different expressions for the area of quadrilateral ABCD. We multiplied equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. Then we took out the root out of equation number 3, and we got that the area of quadrilateral ABCD equals to the root of this expression, and the root of 4R squared equals to 4R. Then we multiplied this equation number 3 by R, and we got that R times the area of quadrilateral ABCD equals to this expression. Then we divided equation number 3 by the area of quadrilateral ABCD, and we got that the radius of the circle that we are looking for equals to this expression. Then we know that xy equals to AC plus BD according to rule number 2. So we substituted xy in equation number 3 by AC plus BD, because AC plus BD equals to xy. So, and we got this expression after we substituted xy by AC plus BD. And then we calculated, so we have here all the data that is required. We have the values of A, B, C, and D. And the only thing that is left to do in order to find out the radius of the circle is to find out the area of quadrilateral ABCD. Okay? And the area of quadrilateral ABCD according to equation number 1 equals to this expression. And S equals to A plus B plus C plus D over 2. We have the values of A, B, C, and D. So S will be equal to A plus B plus C plus D over 2 is actually 9 units. So we put the value of S inside this equality, and we got that we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Okay, so we substituted the area of quadrilateral ABCD by the root of 360 square units. Okay, and we got this expression. So the radius of the circle equals to 1 over 4 times the root of these expressions. And we have the values of A, B, C, and D. We put the data inside this equality. For example, A is 3, and C is 5. So A times C is 3 times 5 is 15. B is 4, D is 6. So 4 times 6 is 24. B is 4 and C is 5. So BC is 20. 4 times 5 is 20. A is 3 and D is 6. So AD is 3 times 6 is 18. And here A is 3, B is 4. So 3 times 4 is 12. And C is 5 and D is 6. So 5 times 6 is 30. Okay. And we did this simple arithmetic, and we got that here 15 plus 24 is 39, 20 plus 13 is 38, and 20 plus 30 is 42 over 36. So it is 39 times 38 times 42 over 36. And we got that this expression inside the root equals to the root equals to 172.9 all divided by 4. So we found out that the radius of this circle that blocks quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. I'll repeat again, the radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay? Thank you very much.